Alrighty guys, hi, it's Miss Bolin, back with your video for today. I really want you to pause, read this through, and see if you can identify it from yesterday. Because this is really, truly a review of what we did yesterday. So, Mr. Contreras wrote the expression up on the board. You use the expression to answer A/B, so that's this expression. Which value represents the base and which value represents the exponent. And then Noah believes the expression simplifies to 64, while Myrna believes it's 12. Who is correct? So, again, we have 4/3, or 4 to the third power, or 4 cubed. So 4 here is the base, and 3 is the exponent. So 4 is the base, and 3 is the exponent. So Noah believes the expression simplifies to 64, and Myrna believes it's 12. So the easiest way to do this is to solve the expression. It would be 4 times 4 times 4. Remember, 4 3 times, not 4 times 3. Which would be 16 times 4, which would then be 64. So Noah is correct. Alright. Helping us understand exponent properties will help us simplify the numeric and algebraic expressions. So it's all about making expressions simplified. Here in C and D, we're going to write the expression in expanded form and then simplify to help us realize what we're going to do in the later things. So we have 3 times 2 times 3 times 5. So we have 3 twice and then times 3 5 times. So 3 to the second times 3 to the fifth. So in total we get 3, 1, 2, 3, 4, 5, 6, 7 times. So we have 3 to the 7th. Here we have 5 to the 5th. Times 5 to the 2nd. So what we can do here is we can cross off, and then we get 5 to the 3rd. So you might have picked up on some rules. If not, we'll go over them. The examples shown show us the two properties that can be used to simplify where like bases are being multiplied. So these are all like bases. Our bases here, the 3's are the same here, and the 5's are the same here. So multiplying like bases is a to the x times a to the y is the same as saying a to the x plus y. So when like bases are multiplied, you keep the base and add their exponents. So you keep the base and you add the exponents. Over here, it would be the same as x minus y. So again, you keep the base and you're going to subtract when you're dividing. So you're going to add the bases when you're multiplying and subtract when you are dividing. So again, I could write out, we have 8 to the 7th times 8 to the 3rd. I could write out 8 7 times and then 8 3 times and count them all up and get 10, or I can just know I have the same base, so I can take those two and do 7 plus 3. I get 10. So my answer would be 8 to the 10th power. Right, this is one with dividing, so you're going to subtract the bases. Go ahead and try this one. I have m here, so the bases are the same. And I'm dividing, so I'm going to take 9 minus 6 and get m to the third. Here's one where I have to do both. Go ahead and try and do this. And then we will go over it. So we have 2 and 5 here. Get 7, so we then have 7 to the 7th power over 7 to the 3rd power. And we can do 7 minus 3 and get 4. So our final answer would be 7 to the 4th power. And this works because it's all 7, so we can kind of ignore the one that we have the same of. So again, I could write out 7 2 times. I could write this out as 7 times 7, and then 7 times 7 times 7 times 7 times 7, 7 5 times, and then 7 3 times, and then start crossing out my similar 7s and get 7 to the 4th that way too. Or I can simplify using these rules. Alright, go ahead and pause your video and try and solve this one for me. And then, where do we go? There we go. Alright, pause your video and try and solve this one. Go ahead and subtract first, and then whatever you get, you're going to add with the multiplication. You're following PEMDAS's rules even with these. Alright, now we're going to explore additional properties when we are multiplying something to a power. So, we have 2 squared 3 times. So we're going to do 2 squared times 2 squared, right? Then we have 2 times 2 times 2 times 2 times 2 times 2 is 2 to the 6th power. Then we have over here 4x squared times 4x squared. So it would be 4 times 4 times x times x times x times x, and so it would be 16x to the 4th. So again, those writing it out, we can sum them up a little bit in these two things here. So power to a power, so a to x is ax to y to the y power would be a times a to the power of x times y. And then here, again, we're going to keep that base. But here, we multiplied the exponent. We have ab to the x power. So we can just break this up and do it as a to the x power and b to the x power. And follow all our other rules, just distributing. So we distribute the power to each factor. So here we have the properties of the exponents both. Simplify the expression, so we could break it down. X to the third power and y to the third power, because we just distribute this third power to each one of those. And here we're going to do a similar thing and then combine. So I have h to the fourth power squared. So I'm going to multiply these two and get 8. So I'll have h 8 times h to the third power to the fourth power. So I got to multiply these two and get 12. And then I get h to the 12th power. Well, now I have some where I have like bases. So I can just add 8 plus 12 and get h to the 20th. Because we're still incorporating those first rules, where if we're multiplying numbers with the same basis or letters with the same basis with exponents, we can add. Alright. Go ahead and pause. I really want you to try this one on your own, and then I am going to go over it, but go ahead and pause. So we have 2 to the third and then 2 to the second here, which would be, you multiply 2 to the 6. So you get 2 to the 6 over 2 to the 5th, and then 6 minus 5. 6 minus 5 is 2 to the first. Or just 2. Alright, go ahead and try this one all on your own. Remember to follow PEMDAS. So just, this one's kind of easy. You just distribute that 5 to each one of those. And remember to follow your rule when you're distributing, that you're multiplying because you're raising a power to a power. Alright, go ahead and pause and try and solve this one. This one's a little complicated. First, raise your power to the power here, and then subtract. Alright, 3 students wrote the following equality statements. Circle the name of any student who is correct. So we can see x to the 4th, x to the 4th, all to the third power would be x to the 12. X to the third, all to the 4th power would equal x to the 12. So this would be a true statement. The next one, we have x times 4, x, or 13th to the 4th statement, or 13th to the 4th power, times x to the 13th to the 7th power. That would be 13th to the 11th power. But it does not equal 13th to the 4th times 13th, because that would equal 13th to the 28th power. Then we have over here, let's see if we can simplify this, would be y to the 9th over y to the 3, which simplifies to y to the 6th power, right? And then we have equals y to the 2nd times what, or y to the 2nd to the 3rd power. So you multiply those and you get 6. So it does equal y 6. So there you go. Now you need to find the value x needs to be true. So we need to go through these, and then we're going to try and find what x needs to be true. So you have b to the 6th, b to the 6th. So you're going to add those and get b to the 12th, and then b squared all cubed would be b to the 6th. So then you have b to the 12th over b to the 6th. And so you're going to subtract that and get b to the 6th. Then you have equals b to the 3rd power, all to the x power. So you know that 3 times x you're trying to get it to equal 6. Well, 3 times x, what times 3 is equal to 6? You could either do that in your head or you can divide. And you get x is equal to 2. All of these that we're trying to get to. So that's, again, break it down. It looks like a lot. Let's first simplify this equation as much as we can. So we have g to the 12. So g 12 over g squared to the x power equals g6. So what would we do if we know we had this? We would know we would do 2x, right? We'd multiply the 2 times x. And then 12 would be, it would be 12 minus 2x equals 6. So then we just solve that equation because you would do 12 minus 2x, right? And you multiply those because it's a power to the power. So minus 12 is negative 2x equals negative 6. And then divide by negative 2, divide by negative 2. You get x is equal to 3. That is your answer. Alrighty, if you have any questions, go ahead and ask. I would love to help you with anything at the back table. Have a good day.